little bit of, thank you, don't talk while I'm talking. Today will be a little bit of a mix of things that you already know, just to review some addition strategies. Because third grade addition is really not that different from second grade addition. But I need to make sure that we have a complete understanding of what addition is. Because in third grade, we just start dealing with larger numbers. Addition is still the same as what you did way back even in first grade. But I need to make sure that we know these strategies so we can start using them for larger numbers.
Like double digits?
So our title today, please, is What is Addition? Rogan, what? I don't know what to tell you. I don't have your math.
I've done 6 digits.
So and I don't need these thoughts right now. Thanks.
Digits.
Our title is on the board. Please make sure you get it in your notebook.
6 digits.
All right. I'm sure we have a good understanding of addition. So tell me, what is addition? I should see lots and lots of hands. You guys seem to be very confident about addition. What is addition? Avery, what do we know about addition?
Addition is when you add up 2 numbers to make a value.
Okay, let's try and revisit that definition without add, because if I don't know addition, I probably don't know add.
When you put 2 numbers.
Okay, so we've got putting, I'm going to say 2 plus Avery, because I think you know you could add more than 2 together. We're just doing 2 as an example. Putting 2 plus numbers together. I'm going to change that ending a little bit. So Avery said we're going to put 2 numbers together to get a value. That's definitely correct. We are getting a value, a worth of that tile. But I want to give a more specific word instead of value. When you are adding, and we're taking 5 pencils over here, that's fine, 3 pencils over here, and putting them together, we are getting something called the total. Right? We've heard that word before. Putting 2 plus numbers together to get the total.
First time I heard that was in preschool.
We're getting the total. Yes.
But you could also put 2 numbers together, like, put 2 and 2 together. Or it could be like you just put them side by side, and it could be 20.
Is that how numbers work, though?
That's more
Okay.
than that.
That would be if we didn't know what those numbers meant. I could see like maybe a kindergartner making that mistake, right? If we said put 2 numbers together. I like that we're critiquing this definition to make sure everyone understands. When we say put numbers together, let's draw an arrow to numbers. And I think, Jordan, what might make it clear is Avery's word. When we put 2 values together. Let's write the word value, for values, plural. So what Jordan is saying is he wants to just make sure everyone knows, and I think everyone in this room does, but just to be clear, that 2 and 2, if we're putting those 2 together, that does not equal 22. That's what he's saying. So he wants to be more specific and say when we put 2 or more values together, that would be equal to 4 as a total. That's what he's saying. Yes.
In second grade,
On a number line, addition is always moving what direction?
forward.
Forward. Let's draw a number line. We know how to draw a number line. Just for easiness, let's just say this is 0, this is 10,
a Jeopardy.
We're going to put a 5 as our midway point, and that's going to be our jump. We're going to say plus 5.
That's not a jump.
So this picture matches the equation 0. That's my starting point. Whoops. It's just because my 0 popped up twice. Have some patience, please. 0 plus 5 equals, and then where I landed, which is 5. Again, I know you know that. I just want to make sure you know that on our number line, addition always moves forward.
Not backwards.
On a number line, addition always in big capital letters always moves forward. Alright, so we're going to go over some strategies. Again, most of these are going to feel very familiar. You don't need to say, Ms. Miller, I already know how to do that. Good. I hope so. But I just want to review them, put them back in your brain so that everyone knows these strategies, because once we start playing with bigger numbers, we're going to need to use them. Okay, go ahead and draw a line underneath what we've written so far. It could be a squiggle line, it could be a straight line. I don't care. Our first strategy is the first strategy you ever learned with addition.
What do you mean?
Counting on. Go ahead and write counting on. That's going to be like your subtitle.
What's that? Counting on.
When we are counting on, we start at one number, one add-in my equation, and count on the value of the other numbers. So, for example, if I have 9 plus 4 equals box, I don't need those announcements. I know that. If I'm using counting on strategy, I'm going to start at 9 and count on 4 more. So on a number line, it might look like this. 9, 10, 11, 12, 13. Yes, if I'm writing, you're writing.
Why does it look blue on
I'm not sure.
computer and
I'm not sure. Some of you have learned, most of you have learned the trick where you can count on any number. So for example, I could start at 4 and count on 9. That will work. It's just going to take longer. 5, 6, 7, 8, 9, 10, 11, 12, 13. I'll still end up at the same number. It's just going to take longer. So most of us have figured out the trick to start with the larger add-in and count on the smaller amount because it is easier.
it is.
It's not a requirement. I can start with the smaller value and count on the larger value, or pay attention, please. However, most of us know if we start with the larger value, we don't have to count on as much. Yes, ma'am.
But if they're equal, you have to.
When would counting on be a good strategy in 3rd grade? Counting on was probably your go-to in 1st grade. Might not necessarily been. But 3rd grade, we're dealing with much larger numbers. Samaya? When would we use counting on in 3rd grade? So if this was 900 plus 400, would you use counting on?
No. Yeah.
do you think?
Maybe when you're using multiplication.
Okay, we learned how to count on those skip counts. Could be. Marley?
Maybe like when you're doing times.
Okay, that's what Callie just said. Okay.
Is it different in the hundreds? Like if you skip count in the hundreds, like 100, like 100 plus 9. Would it still be the same thing if you did it differently?
I don't understand your question. So Marley noticed, hey, this is the commutative property. It looked a little different to get there, but we ended up at the same value. We learned about the commutative property with another operation. Cole, what was that operation that we did commutative property with?
Oh my god.
Ava, do you remember?
Multiplication?
We did it with multiplication, remember? 2 times 3 gave us the same value as 3 times 2. Just looked a little different along the way. In 3rd grade, this is important. We're going to write it down. In 3rd grade, we use counting on for small numbers, like 4 plus 9. That's a small number. I can do that.
5 more
Or
numbers.
skip counts. That is it. In 3rd grade, counting on cannot be your strategy for 75 plus 36. That's too large. That's too much counting on. In 3rd grade, we will use counting on if we're only adding small numbers, or we're adding skip counts. So if I say, what's 25 plus 30, I could use skip counts of 10 to do that 30. Does that make sense what I'm saying? Or if I said 100 plus 200, I'm not going to count out 200. But I could do skip counts, right?
100 plus 200
That is
like
appropriate
1
for
plus
3rd graders.
It's like 1 plus 2.
So far, so good? So far, so good. Right. If you have space, we're going to do another strategy. If you need to turn the page, that's fine. Our second strategy, doubles. Go ahead and make your new title or subtitle doubles. Doubles we won't spend a lot of time with. I just want to make sure we know our doubles. Doubles is just a good strategy to have in your brain. We should know our doubles because we know that our doubles is really just our 2's timetables. What's a double of 4? Not the right question. What's the doubles of 2?
4.
4.
You kind of tell.
Doubles of 3.
6.
Doubles of 4.
8.
5.
10.
6.
12.
7.
14.
8.
16.
9.
18.
10.
20.
Some of you probably stopped here. We're adding 11 and 12. What's the double of 11?
22.
22.
24.
24.
That's the right number.
Yep. We do need to write that down. This is a good strategy to use if we are doubling something, which a lot of you use doubles when we were first learning multiplication. You double the value. Smart when we're dealing with larger numbers.
You're counting by
The next strategy, I know you did in 2nd grade. You might have even done it in 1st grade, I don't remember. But it is the most important strategy because we definitely use it in 3rd grade. So you're going to need to be fluent with it. That means be able to do it. Make a 10. When you were in 1st and 2nd grade, you just did make a 10. In 2nd grade, you learned how to do make a multiple of 10. This is the most important strategy. So for example, we've done this with multiplication kind of. If I have 7 plus 5 I could use counting on for that. It's small numbers, that would work. But instead, I'm going to use a break apart strategy.
I use this all the time.
Awesome, love that for you. And I'm going to break apart my 5 into values that would make that 7 a more friendly number. 7 is not friendly. 10 is so easy. I love 10. 10 is the easiest number for me to add with.
Yep.
So what could I break apart 5 into that would help that 7 become a friendly number? Make sense?
1.
So if I add 7 plus 1, I'm still going to get 8, which is not a friendly number for me. 3, because 3 plus 7 makes 10. That's a much friendly number. Julian, do you know why we broke it into 3? Wait, can you want to say it one more time, Julian? Make sure you're listening.
Because it's equal or because it's a friendly number.
Our 3 is going to make that 7 into a friendly number. What friendly number, Julian, will that become? 10. But Julian, wait. We had 5, and we only did 3. Do I have any left over that I didn't use?
Yeah. No.
So I had 5, right? And I used 3. So what did I have left over that I didn't use? 2. 2 is still there.
You're like I'm the smartest person and like 5's the most dumbest person.
So 7 plus 5 is equal to 10 plus 2. Yes. I'm glad some of you are like, I got this, Miss Miller, that's fine. I just need to make sure everyone knows the words I'm saying, because the numbers will get larger. So Colby, these 2 equations are worth the same. They just look a little different. I rearranged it to make it easier for my brain.
Yeah.
For me, it's way easier to do 10 plus 2 than 7 plus 5. Does that make sense?
Yeah.
All right, let's talk about a multiple of 10. This is like the kicked up version. 25 plus 7. Now, I could break apart from my 25 to make that 7 into a 10. But we could also make a multiple of 10. So what that means is a skip count. So are you with me? A skip count of 10. My next skip count from 25 is going to be 30. Right? 10, 20, 30. Skip count of 10. How many numbers is 25 from 30? How many numbers is 25 from 30? How many more numbers do I need to get there? Remember? 5. I need 5 numbers.
No, let me think.
To get from
7.
25 to 30. Because 30 is my goal number. That's easy peasy for me. Colby, if I use 5 from my 7, how many do I still have left over? 2. Beautiful. I know, Bowen, I know. So now I've got 30 plus 2. 32. This is the place value strategy. Place value strategy. The words place value literally mean which place a number is, means it has a specific value. You know this. When I'm dealing with a 3-digit number, if I put a 2 here, what does does that 2 mean? 200. That's different than if I put a 2 here. What does that 2 mean? 20. That's different than if I put a 2 here.
2.
That's what place value means. It means wherever I put a digit changes the value. Okay?
My hair
So-
on my face.
This place is equal to hundreds. This place is equal to tens. And this place is equal to 1. Most of you know that. We've been doing place value pieces. We know what those look like. So far, so good. I've seen a lot of you do this. If I have 25
Come on.
plus 32, all right, we are writing, friend. I'm seeing friends take the tens. So I have 2 tens plus 3 tens. What is 2 tens plus 3 tens? Emma? 50. 5 tens, aka 50. And then we do our ones. 5 ones plus 2 ones. 7. And then I add up those values. 50 plus 7 is 57. This is called place value because I'm adding my numbers in the same place. I'm adding all my tens. And I'm adding all my ones. Raise your hand if you use this strategy, because I've seen quite a few of you use this strategy before. It might not be your go-to. My strategy changes depending on what the problem is. That's good. It should. But how many of you have used this strategy? Nice.
Go.
All right. So we've got one problem we're going to work together before I give you a task that we're going to do. All right. This word is reasonableness. You're going to see this word. Reasonableness. Write it down because I need you to be able to read it. Reasonableness. This word is a fancy way of saying, does this make sense? For example, if I'm thinking, okay, 3 times 5, 3 groups of 5, a reasonable answer might be maybe around 10-ish. A not reasonable answer would be 100. What? Does 3 groups of 5 make sense that it would be 100?
No.
No. Reasonableness is kind of like estimation. What's like a close to number that would kind of make sense? That's what it's talking about. Does that make sense?
It's amazing.
Okay. So let's look at a problem that has this word in it. At the sweet shop candy store, they sold 244 lollipops and 178 gummy bears in a week. How many candies did they sell? What would be a reasonable sum? The word sum, spelled this way, is talking about the total.
Sounds like something on
Total in an addition problem.
I'm writing this down then.
Read that problem. What could be, I don't want an exact answer, an estimation. What could be a reasonable guess for how many gummy bears they ate in a week? Or how many candies they sold in a week? What would be a reasonable answer? It might be easier. What might be a not reasonable answer? What would be like a really bad answer? That might be a better place to start.
2.
Marley says 2. 2 2 would be a really bad answer. Cole? 100 would be a really bad answer. Because I know they've already sold more than 100 in just lollipops. 1,000 would be a really bad answer. What would be a reasonable answer?
Google. 200.
We're not yelling out. We're raising our hand like everybody else. What could be a close to reasonable answer? Connor, what do you think?
Maybe like 420.
Okay, 420. How did you get there?
Because I just added up, like, I can see that 70 and 40 are probably going to make up another 100, and I see 100 and then a 200, so I just thought maybe it's just like 420.
Okay, so Connor said, I saw 244, and I pretty much made that 240. 178, and that pretty much became 170. He added his hundreds, that became 300. 300. 70 and 40 is about another 100.
So 400.
So about 400.
Yeah, around 400.
Archer, what do you think?
I did in my mind, so I put the strings together.
Yep.
And then that got me to 300.
Yep.
And then I looked at the 178. And I took that number.
Yep.
And then I took the 4.
Nice. Yeah, very similar to what Connor did. So a reasonable answer would be they probably sold around 400. The reason we care about is this reasonable? Because when I add it, I should get a number that's close to 400. What if I get a number that says 700?
Then you're wrong.
That's like
Then I'm wrong. That's why we care. If I get a reasonable answer and I say, okay, I know my answer should be like 400, and then I end up with 200, I know I did something wrong. And you don't gotta wait for Miss Muller to say, nope, that's wrong. You already now know it. So we care if it's reasonable. We can see, am I close to, am I gonna be right? Does that make sense?
So the answer is 400.
On your task day. On your task day. I want to see you give me a reasonable answer, a guess, an estimate, and then solve it for real. You can use any strategy you want to solve it, live your best life, whatever makes sense for you. I'm looking to see what knowledge you have so I can figure out what I need to either reteach you or go from there. I don't want to waste your time. I know today felt like I was wasting your time because we did a lot of review, but I need to make sure everyone knew those words. But now we're going to move on based on how we do on this task. Connor, what do you know?
Will we be working in partners?
Absolutely not, because I need to know what you can do.